next problem is called linked list cycle. We are given a head of the linked list, and we have to determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in that list that can be reached again by continuously following the next pointer. Internally, pos, which is basically the is used to denote the index of the node that tail next pointer is connected to. Note that the pos pointer is not passed as the parameter. We have to return true if there is a cycle in the linked list. Otherwise, we have to return false. So in example 1, we see that we can reach the second node by either going from the first node using the next pointer of the first node or using the next pointer of the last node. So it's basically reachable in two different ways. And it forms a cycle with nodes 0 and -4. If we go to the constraints, so for the constraints, we have the following. The number of nodes in the list is in range from 0 to 10 to the 4th. So we are kind of looking for a linear time complexity solution. The node values are from -10 to the 5th to 10 to the 5th. The pos is either -1 or valid index in the linked list. So if there's a cycle, it will be a valid index, or if there's no cycle, it will be just outside of the valid indices for the list. There's also a follow-up that says, can we solve the problem using constant memory? So let's just first try to figure that out. So the brute force solution to this is to use any data structure that can help us remember which nodes we have already crossed, which nodes we have already iterated over. So for that matter, we can use a hash set. So once we go to a node, we would just insert it into a set, and for each node, we would be checking if it exists in the set. If we encounter a node that is already in the set, that means that we are visiting it for the second time. So that means there is a cycle. But in that case, we will have at worst linear space complexity as well. To solve this problem, we will be using the hare and tortoise algorithm that we have already used for one of the problems in the array category. So basically, the concept of the hare and tortoise is based on the slow and fast pointers. Basically, if we put our fast pointer to move 2 nodes at a time, and the slow pointer to move 1 node at a time, if there is a cycle in the list, eventually both of the pointers will end up in the cycle. And because it's basically infinite, they will continue to infinitely move throughout the cycle. And eventually, because fast pointer is twice the speed of the slow, they will basically meet. Let's just do one example. And so if we make our pointer slow and fast to point at the head of the linked list, and if we move the faster 2 nodes at a time, so initially it will point to the second node, but because we are moving it twice, it will point to the third node, and the slow will be moving on 1 node at a time, so it will be pointing to the second node. In the second iteration, we will move our slow to point to the third node, and the fast will initially move to the last node, but because we have this like back relationship with 4 and 2, basically the tail is now pointing to another element in the list. The tail node is pointing to another element in the list. We will move to the second. So the fast will be pointing to the second node. Finally, the slow will move to the last element, but the fast will also move to the last element because it will first move to the third and then to the fourth again. So they will be pointing at the same element. In this case, we know that there is a cycle, but if we didn't have this relationship this next relation from the tail node to the second node, basically we would just finish iterating the list, and the slow and the fast would never meet. Basically, the slow would have crossed the half of the linked list, half nodes of the linked list, while the fast has iterated over the whole list, and they would never match if there wasn't a cycle in the list. If there is a cycle, they will eventually meet, and because we will just return true. And because we are not creating any additional data structure, we will have constant space complexity. First, we will make our slow and fast pointer point to the same node that the current head of the list is pointing to. Then we will move as long as the fast pointer is defined, and also the next value of fast is defined. So basically, the last element you will iterate over will be the last element in the linked list. Then we are moving our slow pointer 1 node at a time, fast pointer 2 nodes at a time, and we are checking for their equality if they are pointing to the same element. If they are pointing to the same element, then we will just return true. If we iterated over the whole list and the slow and fast were never pointing at the same node, we know that there is no cycle in the list, and we will just return false.